Hi, welcome to today's session on the area of segments in circles. So, when we are talking about a segment, we are talking about a line that is touching one side of the circumference to the other side of the circumference, but it does not pass through the center, because that line would be the diameter, but it could pass through anywhere else. So this one is shown by the line AB, and there's two different types of segments. We've got our minor segment, because it's a smaller segment, and we've got our major segments, and this is a lot larger. To calculate the area of a segment, so let's say this minor segment here, what we are looking to do is we are going to draw radii, two radius, away from our center, touching the outside of our segments that we are looking to calculate the area of. And what we'll need to use is the area of this entire sector, so AOB, this entire sector here, subtracting the area of AOB triangle, and that will leave us with this area just inside here. So the formulas that we're going to need to do this is the area of a sector, which is our angle, our sector angle, divided by 360 times pi r squared. And we're also going to need our area of a triangle using trigonometry. So half AB sine C. So I'm going to use an example for this. So we've got radius lengths of 8 centimeters, an angle size of 100 degrees, and our length of the base of our triangle here of 12.2 centimeters. So the area of this sector is going to be 100 divided by 360, because we're looking for this fraction of the circle, times pi times 8 squared. And that's going to give us, when we put this into a calculator, an area of 55.85 centimeters squared to 2 decimal places. And that's the area of all of this. Now we're going to calculate the area of this triangle, and we're going to then take that away. So the area of triangle AOB, so this area here, is a half times 8 times 8 sine 100. Putting all that into a calculator, that gives me an area for this triangle of 31.51 centimeters squared to 2 decimal places. We're only looking for the area of this segment here. So we've got the total area, we've got the area of this triangle, so we are going to subtract our area of the triangle away from our sector area. So 55.85 subtract 31.51, that gives us an area for the segment of 24.34 centimeters squared to 2 decimal places. Now, I've just shown it using trigonometry, but you can possibly also use Pythagoras for this. So I've got the exact same problem. So to work out the area of the sector, I'm going to do the exact same. So 100 divided by 360 times pi times 8 squared. And as we saw before, that's 55.85 centimeters squared to 2 decimal places. But now we are going to use Pythagoras, so I'm going to calculate our height. So if I put in a vertical line going straight down from the center of the circle, perpendicular to our line length before, which was 12.2 centimeters. So the midpoint of that's going to create 6.1 centimeters, which is going to be our length from M, our midpoint, to B. But because our line is a perpendicular line, so it's cut this triangle in half, our angle here now is 50 degrees. So using using Pythagoras for this, our height squared is going to equal our 8 squared, which is our hypotenuse, our longest side, or our C. 8 squared subtract 6.1 squared. Putting all this into the formula, that gives me a height, because once we square root this, that gives me a height of 5.18 centimetres to 2 decimal places. So this means if I put this into my area of AOB, 1/2 times 12.2 times 5.18. That gives me 31.60 centimetres squared to 2 decimal places. And then subtracting, that gives me 24.25 centimetres to 2 decimal places. If you like what you see, please subscribe. Thank you very much for watching.